Hi, everyone. Welcome to join this week's SIG scheduling meeting. This meeting is being recorded, so being respectful to each other, and they will be public. Firstly, let me share my screen. And yeah, so today the first topic is a CAP about the path scheduler readiness. So I think I'll give some high-level introduction on that. 1 second. So the background is that if you know how the internal schedule, especially the scheduling queue works, is that once the path is created, and the path will immediately enter the scheduling queue and then opt out for scheduling unconditionally, no matter the path is like waiting for some external condition like a quarter check or something else. But this is, you have no control on this. The path created and enter scheduling queue, and it will have some internal backoff timer, but it will pop out and enter the scheduling cycle. So in some cases, the path are actually not ready yet because there's some other controller controls that the readiness, but it still goes to scheduling cycle and also goes to the preemption check, etc. So it will waste a lot of cycles here, especially if you consider this is the multi-tenant environment. The cycles wasted on this kind of paths will postpone the scheduling time of other paths, right? So it will indirectly to impact the latency and the overall throughput of the scheduling. So one thing we were thought is that maybe we can just add some knob here so that we will give the user some control to say, okay, for paths that meeting this kind of criteria, then it should pop out. Otherwise, you should just stay inside the unscheduled queue of the internal scheduler. So that is what we propose. And the background, the first version of this proposal, which was in Google Doc, is that we add a in-queue extension point on that, so user can implement the extension points as a in-queue plugin and control that. And later on, the discussion went to like, so if we control everything, the scheduling plugin, maybe it's will get less adopted because not a lot of people has the expertise of writing and compiling scheduling plugins. So the proposal finally comes to a shape is that, okay, you can't just purely use the extension point, use the in-queue plugin and implement whatever you want. But otherwise, if you don't want to recompile the scheduler, use extra plugins, we provide something, a new field called scheduling gates, so that a typical workflow is something like the user I would say the SIE or administrator create the path carrying some scheduling gates. Each scheduling gate is mapped to one criteria condition that the path should be pre-qualified. Otherwise, you will just stay there, not wasting scheduling cycle, just stay there in the non-scheduling queue. That is the path creation. And after that, your controller is responsible for remove the scheduling gate one by one, not one by one, but just remove the corresponding scheduling gate that you are responsible for, like removing full and removing bar or removing all in one time. So that is, and in the scheduler perspective, there is a default enabled in-queue plugin that will check whether the scheduling gates is empty. If it's not empty, it will not let the pod go. You just put it there, gate it there, and let it be in the internal unscheduling queue. So I will give you some demos on it. But if you have any questions, just feel free to ask. So I'm gonna compile the. Go ahead. Yeah.
Mostly because I'm out of date with the CAP. So initially we were suggesting to add conditions, right, to the pod. So that's no longer the case.
So yeah, it's not exactly the same as the big network's readiness gates, because we don't want to use a condition to act as a mapping, and also don't want the condition. We don't want to enforce like the one-way transition on the condition itself, because if you look at the design of the SIG network readiness case, the condition is that, okay, it's the best efforts that you should have the condition. Like if the condition is true, you shouldn't make it false. But in practically, there's no logic in enforcing that. That means you can still just flip that true and false, back and forth. So that is not the thing we want. And also, the condition is more weak enforcement if we want to maintain a state machine, right? So that is why we just want the spec itself to enforce the transition state. So you won't see condition, but there is some condition literal I will show later that will give you better user experience, and also integration with cluster autoscaler to help you better understand which paths scheduling gated and which one is pending. So pending is more indicating that the path has been schedule attempted, but it's just cannot schedule due to other constraints.
I see, thank you.
Yeah, so for now, you can see that I just compiled the local Kubernetes source code because it's not available in the upstream yet. It's just 3 PRs race. And I don't have Node, and my version is 126. So I'm gonna leveraging a tool called Cork to simulate a couple of nodes. Like in the right hand, I just spin up Cork, and I'm gonna raise 2 nodes. Each has 4 CPUs. Node 2 is the same, 4 CPUs. So that I should see 2 nodes ready. Okay, and then I will give you the demo. Let me remove the request first. And I think I can show you where's that? Okay, I can see all the function points that is implemented already. So the first one is that we enforce some check. Like the first one is you cannot create a pod with a no name and non-empty scheduling gates. We will reject that. So for example, this case, suppose I'm using an external controller, but somehow I misuse the scheduling gates because I specify a non-empty scheduling gates along with no name. So in this case, there's some logic in the API side to reject you because it doesn't make sense. This part are not scheduling ready because it carries scheduling gates, but you are assigning a no name to that, so it doesn't make sense. And if you want to do some trick to work around that, like if you want to create it normally without the no name like this is acceptable because you doesn't specify the no name. So in this case, okay, the pod can be created. And you will be staying scheduling gated status instead of pending. So that is the user experience improvement. But if you want to do some trick to, let's say, specify a binding for the pass part to node 1, let's take a look whether we can reject that. So this binding is also rejected because you are trying to make the path into a nonsense state, right? With a no name, but carrying the scheduling gates. So in this case, we enforce some nonsense situation. And also there's so by default, the path, if the path goes through the scheduling cycle, it will carry a condition with type path schedule, but with reason unschedulable, because it indicates the path has goes through the scheduling cycle. But if the path carries the reason schedule gated, all the consumers should be aware that the path is right now just staying in the gating the condition. You don't you may don't want to do some like provision some new license, like in terms of the cluster autoscaler to help scheduling this part. That doesn't help. So this is the default condition. And also, once the part has been transit to the next state, which means it's no longer gated, then the reason will continues back to the unschedulable. So that is also one thing. And this has a new status column in kubectl part. This also has been demoed. And
Is there
ahead.
A way where so the controllers that are using these gates, can they introduce some detail on why they are holding certain resource?
Not quite. We don't have that interface. It just says gated. And if your controller wants to append some condition, it's arbitrary condition. So it's just best efforts, just totally up to you.
Makes sense. Sounds good.
Okay, let me demo a happy path of the path scheduling using the schedule gates. So I delete the part, and let's say, okay, I will just use the default scheduler to schedule it. And in the beginning, I just carry it to schedule gates. Okay. Because it carries scheduling gate, so it will scheduling gated, right? And then if I do some inaccurate thing, like I'm gonna append a new scheduling gate, because as I mentioned, we enforce the one-way transition. Once the scheduling gates can only be applied in the pod creation time, and after that, the scheduling gate can only be removed instead of addition. So in this case, if I want to add a new scheduling gate, it will be rejected because it can be removed after, can only be deleted after the time. So originally I have foo and bar scheduling gate. Now let's say we remove bar. Let's take a look whether it went through. Yeah, it's. So you can see that, okay, in the scheduling gates, it's updated with only the foo. Because it's still carrying one scheduling gate, so it will be still scheduling gated. And then let's remove the remaining one. In this case, we expect the pod gated has been released, then it went to regular scheduling cycle, and then it should be scheduled because I have 2 nodes, right? Oh, sorry. Yeah, it's supposed to be running. Okay, this is the one case I want to demo. And also I want to demo is that, let me see if anything else I miss. Second thing. Yeah, there's some metric, but I haven't prepared a demo for metrics. I think the rest of the demo I have is say, okay, I have 2 nodes and each node has 4 CPUs. And let's say if I specify 10 CPUs, and then I have 2 scheduling gates, let's enable the cluster scaler to see whether it will break classical scaler or not. So for now, the pod carries 2 scheduling gates. Let's say we apply this, and it will be, as I mentioned, it will be scheduling gated status. In this case, we don't expect the class autoscaler to trigger provision a new instance because it doesn't help. The gates hasn't been released yet. So let's take a look at the class autoscaler. And we don't want CA to spin up new nodes. So for now, it's not yet. Let's give it another couple of seconds for it to. So I suppose there's a interval like 30 seconds or something to check the cluster situation and then act on the unscheduled path. But we have consulted with them, says, okay, we have a new reason for this kind of part, so we don't expect you to provision new instance. Again, yeah. So that means CA is really running, but it's not spinning up new instance. Then we are gonna release the scheduling gates. Then because it requires 10 CPUs, right? The first thing we expect with this action is that, okay, scheduling gates has been lifted, so it should go into the regular scheduling cycle. But the scheduling cycle, because of we don't have 10 CPU nodes to fit it, so it will be pending. And then the pending will trigger the cluster autoscaler. Well, that is what we expected. So let's take a look. So I suppose it should be right now pending, and the pending should trigger the cluster autoscaler. Pop didn't trigger scale up one efficient CPU. I'm not sure if my implementation has some issues on this. I suppose have a 32 CPU. It should spin up a new instance. But I'm not that sure.
Well, it doesn't matter. Like what matters is that the scheduler,
Yeah.
they tried to schedule the pod, it failed.
Yeah.
If we can look at the where is the status? The conditions. If you can show the condition as well, it should show unschedulable.
Yeah.
Yeah, and then
yeah.
Unscheduled. So that's what matters on our side.
Yeah, I think I implemented the CA integration when it was 124 release, but I'm not sure if the latest default policy changes, because by default, like you don't have CPUs, but the new instance can have enough CPU. It should trigger a scale up, but yeah. Anyway, but it doesn't impact the current feature of the pod scheduling gates. Yeah, I think that's pretty much I want to demo today. Yeah, about pause sharing. And any questions?
A silly question for me. So is run the cluster autoscaler on your laptop for the demo? Is that part of the Kwalk
No, it's
thing?
not.
No, it's not.
No.
Okay.
Yeah. So basically, the Qualk project is aimed to, like, if you are familiar with integration, how integration test is that it's a bare bone control plane. And then you just create the node objects, but the node objects should have some accumulate-like components to maintain the heartbeat from the node objects to the API server. So it looks like a real node, right? So the Qualk component, the Qualk project is supposed to doing that. It maintains the heartbeat from the fake node object to the API server, as well as the pod condition. Because if you think of integration test, we don't have Kubernetes, then the pod will stay in pending state. Because even if you assign a node name to the pod, there's no party responsible to bring it up, right? So that is also Qualk doing. And then as Qualk is sort of like components, I internally implement a Qualk SIG autoscaler, and then it will kind of just spin up new instance, etc. Yeah, that is what I'm doing underneath, but it's not part of the CAP.
Thanks.
Yeah, I hope this CAP can get some more feedback, because the next release is alpha. We do hope to hear more on how you adapt your use case to this CAP. Like some use case I heard is that, like in Cloudera, they're trying to use it in their unicorn project so that they have some quota check. And before the quota check is down, they don't want to wasting the scaling cycles. And I guess different companies and different project has different requirements, and this feature can be leveraged. Yeah, we have almost 20 minutes. I think, Abdullah, you should have this in today's agenda, right? You want to discuss this?
Yeah, I just oh, what?
Yeah, you put it in the yesterday's.
Yeah, you demo 2 meetings. I didn't see the.
Okay.
Yeah, I just wanted to propose this idea of, like, we discussed pod group before. In my mind, I want to have the concept even like more global, like introduce something called reservations. And we discussed this before. The initial proposal that I had in the document that I shared was basically mostly related to reservations at the pod level. Like, we create a reservation object for each pod. The concern here is two parts. First, well, I mean, if for each pod we want to create an object, that's too expensive in some cases. And the other is, it doesn't quite solve the all or nothing problem completely, because, well, even if it is eventual consistency, like you keep adding, like you keep scheduling these reservations, and then once all the reservations of a group is scheduled, then you start the job on them. That's fine. The job itself is going to be all or nothing, but the reservations themselves might basically end up in a deadlock, because, you know, 2 sets of reservations are trying to get scheduled, and they could basically starve each other. There are some solutions around this, right? Like you can do preemption, etc. But it's, again, that seems to me, again, like might be too expensive as well. Like, yeah, there is no central point that says, okay, this is a group that I want to basically place together, right? So I want to introduce this new idea in the document, but I wanted just to float it here first, which is something similar to pod group, but it's not just identifying pods that needs to schedule together, but it's actually something like, I want to reserve 10 instances of this pod template, okay? And this reservation is going to be scheduled as one by the scheduler. We can talk about how we implement this later, but I wanted to describe the API. So the object itself is going to basically act, imagine like endpoints. If you remember that with endpoints, you track all the pod IDs, IPs that are related to specific service. Here's the same thing, like you have a reservation object. You can say, I want, in the simplest case, I want 10 instances of this pod template. And then the scheduler is going to find, for example, 10 places, and we will track them in this pod object. So in this pod object, you're going to have a list of nodes where all these reservations has been, made. Pods can schedule in these reservations similar to what I made, similar to my, proposal here. Like a pod will have an affinity to the reservation. Now, this basically makes it more explicit, the idea of a reservation as a group for both the scheduler and autoscaler. And it is more generic than the pod group concept, which is basically it's only a scheduler one. It doesn't really solve the problem of reservations. I can see this being implemented in two modes. One is trickle down. Basically, I want 10 instances of this pod, and then the scheduler will continuously try to find 10. And then, it can add them over time if it doesn't find them in the first, in one go. And so the reservation object is going to continue to basically, you're going to continue to see nodes being added there as, where these pods could schedule. Or another mode of operation is all or nothing. Like you either going to find me all these pods, which could be implemented similar to how we're implementing pod group right now, or not. And then when you find them, you're going to actually, record these nodes on the object itself. And then the pods will basically schedule on a second cycle. Like when you create the pods later, they have an affinity to this reservation object. The scheduler will basically schedule them only if there is a reservation object that these pods have affinity to. So I want to add this also proposal here to this. Like we have, I don't know, 3 or 4 proposals here around these concepts. And the reason I'm pushing forward, like I'm trying to find a solution in this context, is because of batch workloads in general. Like the concept of reservations, I think it's useful. It will also, similar to how we were thinking about scheduling gates, it allows higher level controllers to manage resources without knowing what the actual workload is going to look like. Like the container itself that's going to run. So the higher level job, it's called a job scheduler, can create a reservation without knowing exactly where, without actually being a job controller on of itself, right? Because it just requests for the resources, and then it will tell the job controller, say, okay, now I got the resources for you. You go ahead and start your pods. So that separation, semantic, I think, can only be implemented by having this, split between having a way to reserve resources and starting a workload. It also will help find, a solution for all or nothing in a probably more sustained way. I have some thoughts how this can be implemented in the scheduler itself, but I'll leave it to the document. So that's just like I had this idea. I wanted to add it to this document and see if how far it can go. My only challenge here is again related to the autoscaler. How is the autoscaler going to do all or nothing allocation in general? But that's yeah. I need to circle back with the cluster autoscaler folks and see if there are any solutions there.
Yeah, I do agree with Abdullah that we should have a abstract API to describe the behavior and guide the implementation. So right now the community has a little bit diverged, and each scheduling like project implement their own reservation logic. So like Volcano has its own reservation logic, and also Alibaba has a project called K-Ordinator, and also it has a resource reservation concept, but it sticks to the scheduling framework. So this is maybe we can look into, because it's not that hacked, it's still using the, but the interesting thing is that it's using I think it's using some fake pod objects or something, but I haven't looked into the details. Yeah, but this is one thing. If you want, I can post the link here.
Yeah, I mean, the fake pod is also one of the options that are listed in the doc that I have.
Yeah.
Another thing that I was discussing there is like the concept of like, a reservation pod, like explicitly add a new mode for the pods. It's like, this is a runnable pod or a reservation pod.
Mm-hmm.
And the reason why that this could be an option is because introducing a new concept for allocating resources is complicated. Like there's so many controllers that depend on that. Like imagine kubelets and kubectl and everywhere. They assume that resources are allocated based on the number of pods, right? Like that are assigned to a specific node. And so everywhere where that assumption is being made, you want to introduce to it the concept of a reservation as well, because resources can be not available on the node, not because of a pod schedule, but a reservation scheduled, right?
Yeah. It's basically introduced the resource reservation, and maybe in the future we can introduce and implement the backfill logic as well, because that's a typical concept in the traditional batch processing scheduling. Yeah.
All right, that's all I have.
Yeah, I think we don't have other items in the agenda. So one last thing to remind is that next Tuesday is the code freeze. So if you have any items to want to get merged into 126, yes, do let us know. Otherwise, just submit the exceptional request will be little troublesome. All right, if no other has some topics, I will stop recording.